All right, so I'm going to go ahead and show you how to evaluate logs when the numbers don't quite match up exactly how you would like. So I'm going to go ahead and do the change of base formula. And when I do this change of base, I need to have my new base, okay? I have to pick a base that is going to work with both 64 and 16. And so I'm going to go small. Think 1, 2, 3, 4, up, 1, 2, 3, 5, 6. Okay, so I'm going to go base 2. The 16 goes to the top and the 64 goes to the bottom. And I'm going to evaluate these two things separately. So 2 to the 4th power is 16. 2 to the 6th power is 64. Now this reduces to 2/3. Okay, so let's see if this actually works when we rewrite it. All right. 64 to the power of 2 and the root of 3. 4 squared. It does work. So the answer is 2/3. All right, so now I'm going to do the next one. I'm looking at my existing base, okay? And now I'm going to look at 1/25. And I want to pick a base that goes with both of them. So I'm going to choose a new base of 5. Okay, so the new base is 5. So 1, that goes here, and 125 goes here. So now evaluate. So 5 is reciprocal squared and cubed. So now I'm going to rewrite it like this. 125 to what power equals? And one other way to think about this is to change the 125 into the base 5, which is 5 cubed. And this is 5 to the negative 2. And if you actually compare the exponents on both sides, you actually get negative 2/3 if you solve for x. Now that's extra work. I prefer just to do my change of base. Okay, so I'm looking at my existing bases. Okay, all right. And log base, I'm going to go to log base 3. Okay. This is -1. This is 4. So that's a reciprocal and a 4th root. I will, however, write it like this. Okay. Yeah, it makes sense to get a reciprocal and a 4th root. Okay. 16 and 64. I think I'm going to choose base 2. Although I think log base 2 of 64, log base 2 of 16. But I'm going to try it a different way. Log base 4 of 64 and log base 4 of 16. Okay, so this first one is, all right, when I change it to base of 2, I'm going to get 2, that's a 4, and that's a 6. Notice how that reduces. Okay, so 4 to 64 is cubed. 4 to 16 is squared. Does it matter if there's more than one acceptable base? Nope. It's going to reduce if that's possible. So this is the answer. Okay, 32 to 64. I'm going to go with 2 because those numbers are both even. Okay. 2 to what power? That's a 6 and a 5. Whew. All right. So 32 to the 6th fifths equals 64. Okay, 81 and 27. So I'm going to go with base 3. That's a 3 and that's a 4. So that's a 3/4. All right. Last one, 8 and 32. So again, I'm going to go with base 2. Okay. So this is a 3 and this is a -5. Notice how when I'm splitting this up, I'm just doing whole number powers. I'm splitting the power and the root portion so that it's easier to think about. So here, 1 over 32. So what power equals 8? Well, in order to solve it this way, you have to take the 32 and change it to that exponent, which is -5. And you have to take the 8 and change it, which is 2 cubed. And then you have to compare these two parts. Well, solve for x. You get x equals 3 divided by -5. Nice work. I hope that helped.